Just a little video to talk about this flyingRC F4 Wing Mini V3 version 3. It looks like flight controller. It's a little gem. It's one of the best flight controllers I've ever used. The first session we're going to be looking at the unboxing of the device, and we're going to do some wiring and soldering, and we'll install it in a plane. Now this flight controller, of all the flight controllers I have built, and I have built many, dozens, you name it, Matex, BDB, other brands way back years ago. This thing is amazing for the size and the price. For $24, you can't beat a deal like that. And this thing is very small, very light. It's great in the small Willows airplanes that I've been building since I was about 6 years old. The model I'm going to put that flight controller in is this little white guy right here. I have one of those flight controllers in there already, but I'm going to put a smaller escape, and I'm going to put the flyingRC escape and the back in there to get less weight. Now that plane up here, this thing, by the way, is 36-inch wingspan. It's the Willows Cessna 172 model. I built many of these during my 74-year career. Up here, this is a Willows model made from a plan that I had purchased in, believe it or not, 1953. This thing right here I bought in 1953. In fact, this came out in 1947, and I think I remember buying that kit and the plan, the whole thing, the wood, the tissue, the plastic motor, prop, wheels, wires. I think it cost me 35 cents in 1953. So I took this one. It's an Aranca made by Willows, 20-inch model, and I just scaled it up by hand, and I built this guy right here. He's 90 inches wingspan. That thing flies like a dream. I put a Sato 4-cycle FA65 in there, and that's turning about I think it's a 13 or a 14-inch prop. There's a video on my channel, one of my first videos of this guy landing and taking off. It flies like a dream. This one flies very good too, by the way, with that little flight controller. So let's take a look at it. First of all, we're going to have a look and see what it looks like as the board itself and how big it is. This thing is only 0.7 inches wide, 1.1 inches long, and it's less than half an inch thick. It's even thinner than that, but if you put the base on it, which is good because you can then stick it on the base into the platform in your aircraft so you don't damage any of the components on the bottom. So that's the measurements of it. Let's take a look at the parameters of this board. It's the main control processor is an STM32F405. Gyroscope is an ICM 42605. The barometer is SPL 06001. Pretty much the same as any flight controller. The galvanometer is an external I2C ammeter. It has support for high-def OSD, 3 UARTs, 1 S-bus, 6 PWM, and 1 I2C. Now the power is 5 volts required to run the main board for the flight controls, servos, etc. Voltmeter, 2.5 to 30 volts. It takes a 1 to a 6S LiPo. It supports ArduPilot, Betaflight, iNav, open source firmware. Weight is about 2.8 grams. Okay, now if you buy the board, you can also get with it, well, we'll look at this first, sorry. The size of it is pretty obvious here. These are 3-pinned servo connectors that look pretty large compared to this board. It's very small, and it's very capable, by the way. Don't let the size fool you. This thing is amazing. When you buy the flight controller, you can also buy it with an escape and a BEC. Let's take a look at the escape now. The escape is that's a 40 amp escape. It weighs only 2.2 grams. It has support for D-Shot 150, 300, 600, one-shot PWM protocol. It supports sine wave startup, low speed, high torque. It's very good quality, very smooth little escape. Now I was going to just use the BEC that's with my current escape, but the escape that I'm using in the plane right now is a little bit heavy, and I think that this escape, along with the BEC that they provide that we'll see in a second, is going to be much, much lighter overall. So that's the escape. The BEC that comes with it is an integrated BEC. You can have different voltages on it. By default, the voltage is 5 volts, which is what I run this flight controller on because I'm only using 9-gram servos with my small plane that you're going to see shortly. You can also have the BEC output 6.2 volts by bridging these two pads right here, or 7.4 if you want to bridge these two here, and 9 volts by bridging these right here. Of course, you wouldn't bridge more than one. You just bridge one or the other, and if you change it to 6.2 and you decide to go to 9, just unsolder this bridge and solder these two together right here. When you order all 3 components, you get the flight controller, flyingRC F4 Wing Mini, Maytech F405TE, and you get the flyingRC Mini Escape 40 amp, and you get the Flying Wing 5 amp BEC. Beautiful packaging. Let's take it out and have a look. So inside this little package you get a plastic container right here, which has your flight controller, and also in another little plastic package you get the battery connection wire. We'll see where that goes later. You get the pins for the servos and escape, and you get the plastic backing for the flight controller with 4 little screws to hold it. All right, so let's weigh that flight controller and see how much it weighs. This is an incredible 3.3 grams, folks, 3.2 actually. And we'll take a look at it once it's all wired and soldered together. So the flight controller with the ground pins, the 5-volt pins, and the signal pins, along with the pin for the 4 pins for the receiver if you're using an ELRS, and the pin on the outside, the pin set for your VTX. That whole thing without soldering is only 4.9 grams so far. Incredible. This is the 40 amp escape package. Unpacked, it looks like this. You get the capacitor and the 40 amp escape board. Now, if you weigh that little escape is only 2.2 grams. If you put the capacitor on board too, it's only 3.2 grams before soldering. Okay, last and not least is our tiny little BEC, 5 amp BEC. And you get a capacitor with it, and you get the BEC board. Let's weigh those guys and see what they sit at. The BEC is 4.2 grams. With the capacitor, it's a total of 4.7 grams before soldering. All right, we've got the pins all soldered into flying RC board. You can see the soldering all done. Now we're going to flash the firmware onto it using iNav. So we'll need a C-type connector, one that's made for data, not a charging cable. They're not too reliable. And what you do is you plug it right into that C-type connector on the board. And you'll see the lights come on when you connect it to your computer in a USB port. Now it's ready for flashing. Just one more thing to do. We don't have any firmware on this flight controller yet, so we can't connect to it. So we have to put it in what's called DFU mode in order to be able to flash it. So now that we know the lights are working, unplug it from the laptop, the power that is. Hold the DFU button down, that little button right there. Just put it down on the surface and hold that depressed and power up again. And now you see the lights are not flashing, they're steady. That means it's in DFU mode. So let's go over to iNav and have a look. So now we see we're in DFU mode. See right here it says DFU. So what we need to do is go to Firmware Flasher over here on the left side, click on that, and say we're going to look for our firmware local, because I have it on my hard drive, and the link to this firmware for this particular unit is in a link below this video. So let's go and see where I've got that stored. I think it's in, let me see, somewhere around here, I think. Where did I put that? Over here, I guess. flyingRC. There we go. And we want iNav 8. I didn't use 7. 7 works, I guess, apparently. I didn't use it yet, but I use 8 for this particular flight controller. Now, I have no reboot sequence ticked off. I have full chip erase. I want to put a brand new piece of firmware on there, so I say flash. And it's erasing. You see right here it says it's erasing the flight controller memory. And it's going to start to flash it now. Okay, programming successful. That means that our flight controller has now been flashed with the proper firmware. Okay, once the programming is successful, it says right down here, usually what I'll do is I'll disconnect the USB now, power down and power it back up. Then you will see a COM port appear right here. I've got COM 4. So now we can connect to that flight controller. And you get a default values panel. And you have to choose what kind of an aircraft you've got. I've got airplane with a tail, so I'll choose that one. There we go. My mouse is a little contrary there, I think. And you see it's saving default settings. Now it's going to ask us which port we want things on. And I'm using a CRSF receiver. It's an ELRS receiver, and I know it's going to be on port 1. If you have a serial receiver, it will be on port 2. Just leave that alone. And I know the GPS port is on 5. on this flight controller. Now after set those default values, you see you've got an airplane on the screen, which if you move the flight controller around, you can see that it is working. It is answering to your movement of your flight controller, just like your plane was flying. Okay, so that's the flashing of the flight controller. Let's take a look at the connections to the board. This is a typical arrangement where if you had your own BEC on an escape, it's a combined BEC and escape, you would connect it on the S1 pins right here. And this is looking at the board with the USB to the left, looking at the top of the board. These are pin rows S1 through S6. And then you have an S12 here, which could be used for another device. And right on the end is the S-bus connection pins. Now, if you're using an ELRS, that would be a 4-pin that would be connected right up here on these 4 pins. And your GPS would be connected on the 6 pins just at the bottom edge right here. So you see it says here S1 to S6 and S12 are connected with, they call it steering gear. That would be your servos, and we'll see that in the next diagram here, where the servos are connected, where I connected mine, and the motor. So it looks like they would connect the motor possibly on S12 as well. Okay. The HD or the VTX connects up here, and you see the power, the battery voltage is coming in to your escape right here. That powers the BEC, and that also powers this whole row of servos right here with 5 volts. Because I'm using in a small model like this only 5 volts. I have 9-gram servos. You see there's 2 more wires coming in here for voltage, and those are to provide telemetry if you want telemetry like voltage and amps being drawn. You have to run the 2 wires in here, and they provide this little cable with the FC and the plug right here. It's a pigtail in the end for the battery, of course. Okay, so let's go on to the next diagram, and that is showing where the UARTs are. You see where the ELRS is connected, that's UART 1. I figured this out. There's no documentation with this too much. Very little. In fact, there's none. UART 5 is your GPS. UART 2 would be the S-bus if you're connecting a FreeSky. I use long range. R9 SX works just great on this this little board right here. And you see your voltage and amperage readouts. You need to wire that battery into that port right there if you want to get telemetry. And here we've got the separate BEC and escape that comes with the unit that I talked about just a little bit back in this video. And what you can do is you connect the BEC, which only has output power, it's got no signal, as in a combined BEC with an escape. So you connect the power, ground, and voltage to the S1 row right here, and then you connect the ground and the signal to the escape. So you get your motor control on this row of pins right here. Okay, so if we go back to this one, you'll see that the elevator is on S3, that's where I've got it. Aileron is on S4 and S5. I'm only using one. I only have one aileron servo. You can use either one if you only have one. And S6 is my rudder. S12, I don't have anything on it. Okay, now if you look at the other diagram again, talking about the GPS for a second here. One of the best GPSs I find on these little models is the Bayesian Chinese BN180 GPS. Very tiny, very small. The only thing I found different was when you make the plug to go into the board on the GPS row right here, be careful because the voltage was in a slightly different place from the Bayesian. So I had to wire the voltage into this plug right here. They're not in a row, in other words, on the cable. You've got to be careful with that you've got the ground going to ground, the voltage going to voltage, and of course the RX going to TX on the plug, and the TX going to RX on the plug. So the BN180 is a GNSS module. It's a GPS only. It doesn't have a compass. I don't use a compass anymore. In iNav, you pretty much don't need it anymore. It's nice to have. It's nice to play with, but you don't really need it. Here's the specs on that little GPS. It's a very, very nice GPS. It connects pretty darn quick, only takes like less than a minute outside. I can even connect it in the living room if I want in my house. Connects pretty quick. Now, an even smaller one is this one. It's the HGL-RC M100 Mini. This is real tiny, this thing. And works very good also. It warms up pretty darn quick. And it's, let me see if I can get this going right here. Here we go. It's got power and PPS on one end. And then you've got the receive, transmit, 5-volt and ground on the other end. So you would connect it on this end, obviously, to the board. Very nice little unit. I like these. This is the little plane that I built in Florida quite a few years ago. I think it was 2007 or 2008. Still flying her. She's still going. That's a little Guillos 36-inch wingspan. I have another one here that has a gas engine in it, no 49. That flies just as well. That's where I'm going to put the new flight controller in, that guy right there. That's the big P-51 Mustang I'm building over there, 100-inch wingspan. Now, if you look inside here, you'll see where I put the flight controller inside. Right there, you can see the little flyingRC is in there, and you might see something weird at the back going into the plug for the USB. Well, what happened there was stupid here put too much voltage through the flight controller and smelled smoke. And it being winter, I knew there were no forest fires around, so it had to be something burning in the electronics. Sure enough, I scorched the board, and I thought, this thing is finished. I thought I had even blown the escape as well, but it survived. And I blew a little component on the other side of this motherboard and couldn't get any power to the servos anymore. So, oh, that is finished. Well, not. This thing is pretty rugged, folks, I'll tell you. This is a tough little unit. So what I did was I made a plug, an old USB plug I had, a Type-C, and I ran the positive wire, you see this one right here, from the servo row at the back. Don't know if you can see it here, it's pretty hard to see. And I was able to power the flight controller again through the USB port. I found out I could do that when I tried to connect it to iNav again, and sure enough, it powered up and I could connect to the board and all that. So I'm getting 5 volts of power from the servo rack into the unit. They're tough, boy. I'll tell you, this thing is tough. It's made tough, and you can't even burn it out. Okay, well that's about it for this session. Watch next time for session 2. I'll be talking about a working install and some videos of some flights. Don't forget to check out the link below this video in the info for the DIFF ALL. Save you a lot of work. Just grab the DIFF ALL, copy the text file, and drop it into your CLI in iNav 8, and you'll have a working flight controller. Also, don't forget to check out the link to AliExpress, where you can buy this great flight controller. See y'all later.